to do an escape. Pull up Arduino. Where'd my mouse go? Here now. There you are. Alright. So this is what the code looks like. So over here so I can read it myself. Alright, so what I've done first is there's that for I2C to work, for the process to recognize it, I have to actually call that library. So first thing I do is I call that library for the communication. I also call the library for the frequency counter. And this next set of lines is where I have the sensor addresses. I have the barometric temperature and sensor right there. That's 77 hex. The real time clock address is 68 hex. And the humidity sensor is 51 hex. So that tells the microcontroller, okay, this is the address whose sensors I want to connect to. So the first thing I do is I set my previous millis at 0. That says at the boot, the time clock processor is at 0 seconds. So what we do then, I initiate all the variables I'll need through an entire program first. Alright, so now interval, that's my 300,000 milliseconds, 300 seconds is 5 minutes. I have an upper sampling setting which for my specific sensor is 0, and these are my calibration values for what I need to get the information out of the sensor that I might need. So here's the setup function. First thing I do is for setup. I begin the serial communication, that way it knows to communicate to whatever I have connected over Bluetooth. Then I call my barometric pressure calibration, and it'll get all the values from the barometric pressure sensor that I will need to calculate the barometer and the temperature. And then it goes into the main loop function. And this is where the timer comes and stands. Is I have a current millis, which was 0. It's now set to the millis function, which is an automatic read to the processor. Says, I need number of millis. Now the processor runs at 16 megahertz, so the processor manually converts it 16 million cycles per second. How many milliseconds is that per cycle? And it gives me that output that I assign. Then I can say, okay, the previous millis, which in this case would be 0, if this number of millis minus that is greater than my interval, it will run my get conditions. Otherwise, it'll move on to my serial available. So what that does is, if it is not time to get a query, I can say, okay, read the command coming out of my serial device with my phone or Bluetooth device. It'll say, if there's a byte available, I want to read it. If that byte is U or capital U, I can, which stands for update, I can do my get conditions manually. Otherwise, if it's a T, I can do a time dump on a real time clock, reset the time, for example, daylight savings time, or if it has an offset, which is generally about 1 second per month or 1 minute per month, then I can come back and in a year I can add those 12 minutes back in. The other option is if it's a Q, it's going to do a data dump on the real time clock. That way I can do a recalibrate completely from a fresh memory stand. Alright, so here's where I do get conditions. First thing I do is I assign previous millis to current millis. That way it says, okay, I've been ran, restart the counter back at the beginning of the loop system. So what I do is I say, for my temperature, get the temperature from that sensor, but it's going to come out as Celsius, so I have to convert to Kelvin and Fahrenheit. Same thing with the humidity sensor. I go and I pull that humidity sensor using the humidity function, but I also have a parameter of temperature Celsius. Then I have a humidity R, which is useful for this while loop, where it says, if my humidity result from the sensor is less than -25 or above 125, that range that I manually set, it'll say, go get that result again. And as long as that result is out of that range, it'll keep getting it until it goes in range. At which point, it will now become the humidity R, which I pass to every other function that I need to pass it to. So from there, I get my pascals of barometric pressure, convert to atmospheres, the millibars and the inches of mercury. Do vapor pressure, which takes my humidity and actually operates on the temperature, and with the vapor pressure, it's the actual pressure of the water in the air pushing down on the sensor. Just like it's air pressure on a tire pushing on the surface of a tire, it's the air pressure pushing on the water in the air pushing on the surface it's in contact with. From there, I can calculate my National Oceanic and Atmospheric Administration formulas for virtual temperature, water grains, and air density. And I can get the date from my real-time clock that says, okay, this is when this read was made. This is when I pulled all these sensors. Now I can add that to my output, which is what serial prints is for. But the thing is, real-time clock is in 24-hour mode. If I want it to show in 12-hour mode, I have to add a statement in here. It says, if the hour is less than 12, print the hour. Otherwise, hour minus 12. And similar to the end, I also have to add the antiperimeter post-meridian. And then I have to say, okay, time since last boot, current milli is over 1,000. And I print everything I found upstairs is now printed out through the serial print line. And down here I have all the auxiliary functions I need to call all the sensors to do data conversion from decimal to binary, decimal to hexadecimal. And that's what this is here. It's saying go hexadecimal to binary and back again. Is those two. I have my set date, which is if I send a T parameter from my phone, it'll say, okay, start reading. It'll actually read an array of what I've sent. It'll say, of the format, there's supposed to be a T right here. T, year, 4-digit year, 2-digit month, 2-digit day, and then time. And this last digit is day of the week. I have it for 6 because I calibrated the system on a Saturday. But what that does is that reads it into an array, and I can say, okay, program that into that real-time clock using the arrays and converting it to hexadecimal, and everything else that a sensor will actually need to read that in computer language. Now I get the date, it's the other way around is, now I'm saying I want to transmit to the address of my real-time clock, send nothing, and then I do a request from that same address, and what that does is I say, I received a byte. That's my second, received a byte, my minute, received a byte, and so on and so forth. And because these have asterisks in front, what that actually does is where here we have a return statement. If there's an asterisk leading that variable, it will actually pass it up backwards as a parameter. So when I say I want to call, let me see what my, when I say get date DS1307, then I can say when I have this star, 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 I can actually reference, and it'll actually pull a variable backwards, and instead of in a return statement, it pulls the values backwards into my print lines. Because you have a limitation of what you can return, it's actually a pass by reference. And then for my humidity sensor, I have my read calibration, and then my offset. And this is for the calibration value inside the humidity sensor, which, nice thing enough for the sensor I got, you only read once. So it's pretty much useless once I have the calibration values. So what I did is I just took those values and said, okay, I don't need to read them again, so I put them directly into the code rather than having to query that sensor. Basically, every other formula is pretty much the exact same. So everything's the exact same as far as pulling a sensor, getting the value back. So that's pretty much all there is to it. And what the end result looks like, it ends up looking like my notepad. And this is what actually outputs as to my serial attachment. So it comes out as my date, my time, and the reading out of every sensor in every unit. And that's the end of the presentation.
First question. I
Alright.
wanted to, what software are you using to allow the phone to communicate to the Bluetooth? Like, do you interface with that software? And one other thing
Right.
is, why did you choose C++?
C++ is actually part of Arduino. That's what they that's the base programming language for the Arduino microcontroller system. And on the other equation for Bluetooth, is it usually works very specifically for Android because it's limited in the iOS for iPhones, but in Android there's apps out there called BlueTerm, and it's actually a serial terminal just like terminal or command prompt, but it's for your phone and communicate over to the microprocessor and pull the values back.
Have you been in a race yet?
No, I haven't. Our last race was 2 weeks ago, and I haven't. And I finished this after time, but I've been doing a lot of prototype testing that's outside during the last storm and whatnot, and I'm getting values to within about 5% of the local airports.
That's good.
So your values could be accurate.
Exactly.
Not,
No,
you're not at the airport.
right. Well, the thing is, with the weather station, as long as you know what the weather station does relative to the weather, how accurate it is isn't exactly important as being consistent with what it's reading. So that's more important is not necessarily being accurate, but being consistent with what it reads.
In terms of precision, to be precise.
Yeah.
Well, what inspired you to make this project and come up with the idea to make a weather station to?
But basically, what it came down to, sorry for cutting you off,
Sure.
this cost me $125 to build. To buy it from a big industry like Precision Air, it's about 800 and some odd dollars for this exact, for a Bluetooth connection, for everything I have in here. That's a significant price difference to make it yourself.
Are you planning on selling these?
Don't know. I've gone on Facebook, so I'm waiting to see what the fellow racers see and see if they recognize it and say, if we don't have one, I can save a whole lot of money. So.
You can get a cheaper chip. You wouldn't need Arduino. You
Right.
custom manufacture.
Right. And there's people out there that where they started with Arduino and they went to their own programming one. But for me as a beginner, I said, okay, the code base is already there. I just have to program it. I saw a question up there.
Yeah, did you write all that code yourself?
Yes, 600 lines. Oh, some of it I get from sensor data sheets because it's already provided, but I still have to say, okay, I need to integrate with the system I'm using. So I still have to write it in a sense. Yes, some of it I source, but I still have to modify it to do what I want it to do.
Got time for maybe 2 more minutes. Time for maybe one more question. No other commenters? Then let's thank the speaker.